So we pick up from where we had stopped in our last class. That now should be question 5C of the paper of last sitting. And question says that Red Rose Limited has developed a new washing detergent. The company is considering whether or not to market test the detergent prior to its launch. Market testing will cost shillings 50 million, which may increase the likelihood of the success of the product if it passes the test. The probability of passing the test is 0.8. If the product fails the test, it is regarded as worthless. So previous data collected was as follows: probability of high success with no testing, moderate, low with the market testing. Launching the product will cost 150 million and the estimated profits are as follows. Now, Red Rose Limited has the option of selling the product design 250. Okay, a decision tree showing the payoff. So these guys have designed a product and they want to decide on whether to launch it or not. So, first of all, we can look at it this way. They have the design. Now, this design, we are told they can sell the design, or they can decide to launch the product. Launch the product. Now, in launching the product, they can do two things. They can test the market or not test the market. They can test the market or not test the market. Now, if they test the market, it will pass the test or fail the test. They will pass the test or fail. Now, if it passes, there are three possibilities. It is high, moderate, or low. But if it fails, it becomes worthless. If they have not tested, again, there are three possibilities. They can get high, moderate, or low. And if they sell the design, they just receive the money, and that's all. They just receive the money, and that would be all. So in that case now, we have 1, 2, 3, 4, 5, 6, 7, 8. So those are 8 tails. So if there are 8 tails, we need to do a decision tree. We need to do a decision tree. And I told you we come here and we write at the end here, payoff. That is where we'll have the payoff. The payoff there. So that now we have our decision tree here. So I have 1, 2, 3, 4, 5, 6, 7, 8. So there are 8 tails. So in this case, our 3 outcomes here. What? Tulisema the broken ones are options. Complete ones are outcomes. You need to check what we gave as the conventions kwa hiyo harat. Okay, so if that is the structure, then we were told that here you can sell. So here is where you sell. And where you sell, you get cash. You get cash. Tracy, good morning and welcome. You get cash of 250. So unakuja hapa, unasema 250. That is the payoff. Then tukirudi huko juu tunaambiwa the company is considering whether or not to market test the detergent prior to its launch. So here it is when you decide that you want to launch instead of selling the design. You sell the design. This is you sell the design. So here you launch the product. You launch product, hapo sell the design. Now here you test. And here no test. Test and no test. We are told market testing will cost 50 million. So 50 million naandiko hapa in brackets, which may increase the likelihood of success of the product if it passes the test. The probability of passing the test is 0.8. So when you test, you pass the test with 0.8, or you fail the test, obviously now with 0.2. You pass the test or you fail. If the product fails, it is regarded as worthless. So here it is worthless. And the meaning of that is that you get nothing from it. The payoff is that you get nothing because it's worthless. Previous data shows the probability of high success when there is no testing. When you don't test, the probability of high here is 0.2. And the probability of moderate, is 0.35. And the probability of low is 0.45. But when you have tested the market, to get high here, the probability is 0.4. And moderate, the probability is 0.4. And rho, the probability is 0.2 when you have tested the market. Timothy, good morning and welcome. Then we are told that routing the product will cost 150 million. So when you route, so here 150 million. 150 million. And the estimated profits are, for the high success, is 900 here. For the moderate is 450. For the low is 225. So the same case here, 900, 450, and 225. So that is okay. Let us now do what? Compute the EMVs. Computation of EMVs. So down there, make a computation of EMVs. Computation of expected monetary values. So when we begin with number one, we say you take those values, 0.4 multiplied by 900 plus 0.4 multiplied by 450 plus 0.2 multiplied by 225. So give me the answer, those are online also. Five into 5. 585. Let us go to number 2. Number 2, obviously here the probability will be 1. So it is 1 times 0. And the answer is 0. The answer is 0. Number 3 is 0.8 times what we have gotten in number 1, 5 into 5, plus 0.2 times what we have gotten in number 2, which is 0. Then you minus, you see this one is coming in, you minus that 50. Minus that 50, which is getting in there. $418. Online. So if that is the case, 418, we go to number 4. whereby we say 0.2 times 900 plus 0.35 times 450 plus 0.45 times 225. Brian, I need your figures. For that 8.75. For that 8.75. So if that figure is okay, we go to number. Okay, good. We go to number 5. So in number 5, you can see the lines are broken. So if the lines are broken, what you do, you select. So we are going to pick the higher of 3 and 4. So is the higher EMV at 3 and 4. So 3 equal 418, 4 equal 438. So we take this one. 438.75. Na hiyo imechukuliwa kwa no testing. So you mark here. Mark there. Then, oh, sorry, there is a cost that is coming in, this one, so we are supposed to say minus 150. Minus 150. So 438.75 minus 150, it is what? 2.75. Okay. Then we go to number 6. Number 6, the probability is 1 year. It is going to be 1 times 250. And that gives us 250. That gives us 250. Then number 7. Number 7 will be the higher. The higher EMV at 5 and 6. The higher EMV at 5 and 6. So 5 has 288, 6 equal, so we go for 5. 288.75. And that is coming from number 5. So we round here. That way. So the advice is they should round the product. Round the product and do no test marketing. So we are saying route the product and no test marketing. Route the product and no test marketing. So I think we have answered that because the question was asking us to show a decision tree showing the payoff and the expected monetary value of each decision. We have done that. And then advise the management of the company on the best course of action and the related expected monetary value. So we are given that. Now in question number 6, in the context of time series analysis, distinguish between the following: mean absolute deviation and mean squared error. I think that one we have discussed, or we discussed in our notes of the what? Descriptive statistics, additive model, and a multiplicative model. They are also there in our notes on time series. So as we advised, make sure you are looking at these notes. They are very, very important to answer those theories. Part B, the quarterly profits of Nyota were tabulated below. So we are told to do 3-quarter moving averages. The seasonal index for each quarter, assuming the multiplicative, you derive the season-wise profits using the multiplicative. Okay. We can combine all that. We did not solve that question in class, so we can combine all that. I hope my space hapa itatoshea. Huko mwisho, I will require the seasonalized profits. We require a column for the seasonalized. I will require a column for the accurate. I will require a column for the estimates. I will require a column for the trades. I will require a column for the 4 moving averages. I will require trade in the center there. I will require a column for the 3 moving. We require a column for the values, a column for the quarter, and a column for the year. Yeah, good. So 1, 2, 3, 4, 5, 6, 7, 8, 9. So 9 columns should suffice. So I'm saying this will be my year. This is my quarter. These are the profits, which shall be my A. And this shall be 3 moving average. Then 4 moving average. Then I will get the centered average. Then I will get the what? The estimate index. The estimate index. Then I will get the accurate index. And then I will get the adjusted values. Adjusted is the other word for deseasonalized. The other one for deseasonalized. Yeah. The other one for deseasonalized. So this is my A. This will be my T. This will be my A divided by T, because we are taught to use the multiplicative. So the title is time series analysis table or analysis sheet, multiplicative model. And remember, multiplicative what tunasema A is equals to T times S times E. A is equals to T times S times E. So this is S, and then it will be A divided by S. So mine, I will have to write here, provide lines. So we have the year 2019. With the 1, 2, 3, 4. The year 2020. With the 1, 2, 3, 4. The year 2021. With the 1, 2, 3. Imekosa kutoshea. Bakisha tu pamoja. You do not have to rule, no problem, because your book is already ruled. You already have rights. There is no harm in drawing the rights again. So we record the values. This is 105. This is 138. This is 116. This is 140. This is 104. 122. 103. 146. 113. 149. 141. 162. Okay, so now we are told to do 3 moving. So he who hatuweki sana, but now the examiner has asked for 3 moving. You take your calc. I told you 3 moving, you add the first 3. So utasema 105 plus 138 plus 116 equals. Then you divide by 3. And that answer is normally recorded at the third value, third line. So unaiweka hapa 119.6667. You can use 4 decimals if you have space, but if you don't have space, you can also use fewer. Then you drop 105. Say 138 plus 116 plus 140. You divide by 3 is 131.3. We just use 2 decimals. My space is not big enough. Then 104 plus 140 plus 116. You divide by 3 is 120. Then 122 plus 104 plus 140. You divide by 3 is 122. 103 plus 122 plus 104 divided by 3 is 109.67. 146 plus 103 plus 122 divided by 3 is 123.67. 113 plus 146 plus 103 divided by 3 is 120.67. 149 plus 113 plus 146 divided by 3 is 136. 141 plus 149 plus 113 divided by 3 is 134.33. 162 plus 141 plus 149 divided by 3 is 150.67. Because that is how you do 3 moving. Let's do the 4 moving. So 4 moving, you take 4 values. So 105 plus 138 plus 116 plus 140 equals, divide by 4. And that value huwa unaandika at the center of those 4. So sasa itaandikwa kwa hii line 124 124.75. Then you drop this 105, say 138 plus 116 plus 140 plus 104. You divide by 4 is 124.5. Then uchukue 116 plus 140 plus 104 plus 122 divided by 4 is 120.5. Drop that, uchukue 140 plus 104 plus 122 plus 103 divided by 4 is 117.25. 104 plus 122 plus 103 plus 146 divided by 4, you get 118.75. 122 plus 103 plus 146 plus 113 divided by 4 is 121. Drop that, uchukue 103 plus 146 plus 113 plus 149 divided by 4 is 127.75. Drop that, tuseme 146 plus 13 plus 149 plus 141 divided by 4. We have 137.25. Chukua 113 plus 149 plus 141 plus 162 divided by 4 is 141.25. Then we center. To center, to remember what you do, you add these two neighboring values. You add them, divide by 2. So to answer part, tuseme 124.75 plus 124.5 divided by 2. I will get at the center here 124.625. 124.5 plus 120.5 we divide by 2 is 122.5. 120.5 plus 117.25 you divide by 2 is 118.875. 17.118.75 divide by 2 is 118. 118.75 plus 121 divide by 2 is 119.875. 121 plus 127.75 divide by 2. We get 124.375. 127.75 plus 137.25 divide by 2. 132.5. 137.25 plus 141.25 divide by 2 is 139.25. Sawa. Aya, so kama tuko sawa, we now start dividing. So as the formula says, so tutaanza hapa 116 divided by 124.625 is 0.9308. We can work with 4 decimals. Then hiyo ingine itakuwa 140 divided by 122.5. This is 1.1429. 104 divided by 118.875. We get 0.8749. 122 divided by 118 is 1.0339. 103 divided by 119.875 is 0.8592. 146 divided by 124.375 is 1.1739. 113 divided by 132.5. We have 0.8528. 149 divided by 139.25 is 1.0700. Yeah, that's all. Now to get the accurate, I told you what you do. Nakuja unaanzia hapa. Here, you see this one is for number 3. So you take this one for number 3. There is another one here. There are just 2 of them. So chukua hii ya number 3, this one. Useme 0.9308 plus hii ingine, hii ya number 3, this one. 0.8592 equals that answer divided by 2 because there are 2 of them. Alafu hiyo answer uiandike kila mahali kuna quarter 3. You write it kila mahali kuna quarter 3. So hapa 0.895. Hapa 0.895. Na hapa 0.895. Tukuje kwa hii ingine ya pili, hii sasa ni ya number 4. So chukua 1.1429 plus kuna mwingine hapa kwa number 4 hapa 1.1739, or they are just 2, equals divide by 2. So that answer andika kila mahali kuna quarter 4. Hapa 1.1584 na hapa 1.1584 na hii ya mwisho 1.1584. Tukuje kwa hii ingine. This one is in quarter 1. So useme 0.8749 plus huyu mwingine hapo kwa quarter 1 0.8528. Niko kwa quarter 1 0.8749 plus 0.8528. That answer divide by 2. So kila mahali kuna quarter 1, and because zimetoka na 5 decimals, write it to 4 decimals. 8639. Kila mahali kuna quarter 1. 0.8639. 0.8639. Now the fourth one, hiyo imebaki ya mwisho, you don't work it that way. You don't work it that way. What you do, you take 4, you subtract the other 3. Because tulisema when you are in the multiplicative, the seasonals should add to 4. Should add to 4. So utachukua hii ya number 1, hii ya number 3, na hii ya number 4. You add them. Then you subtract the answer from 4, you do it, the second one should be what? So I'm saying, I will say 4 minus 0.8639 minus 0.895 minus 1.1584 equals. So the answer that I'm getting is 1.0827. Now that is for the second quarter. So iandike kila mahali kuna quarter 2. 1.0827. 1.0827. So that is now what the examiner was calling the seasonal index for each quarter. The seasonal index for each quarter. Then you adjust. You adjust the values. So to adjust the values, you simply divide. So hii ya kwanza nitasema ni 105 divided by 0.8639. I can make it, if I am not working with decimals, I will work with 122. 138 divided by 1.0827. This is 127. 116 divided by 0.895 is 130. 140 divided by 1.1584, 121. 104 divided by 0.8639 is 120. 122 divided by 1.0827 is 113. 103 divided by 0.895 is 115. 146 divided by 1.15, 1.1584, 126. 113 divided by 0.8639 is 131. 149 divided by 1.0827 is 138. 141 divided by 0.895 is 158. 162 divided by 1.1584 is 140. It's 140. Okay, so I believe that is okay. So we have answered Roman 1, that is the 3-quarter moving averages. Roman 2, the seasonal indices. And number 3, we have the seasonalized, the values. I told you the word adjusted, the other one for the seasonalized. Question 7, explain the meaning of the following terms in the context of probability theory. We have mutually exclusive, independent, you know that. Then we are told a linear programming problem has been formulated as follows. We have the objective function subject to you're given that you are required to get the open production for X and Y using the simplex method. So if you're using the simplex method, we're using the simplex method. We already know we already have been given the formulation. So you don't have to copy it again. You just go straight and design what I told you is called initial simplex table. Initial simplex table. And you don't even have to do the step that I told you is called changing the inequalities, because you know that we are going to add s's to each equation. So if that is true, we have how many equations? We have 3 equations. We have 3 equations because the last one is non-negativity. So we are going to have 3 s's. And I told you each s will have its own prime. So the first one, the second, the third, then we will have the Cj, then I will have the Zj, then I will have the Bj. So I told you this is called column C. This is basis. We have S1, S2, S3, Cj, Zj, and Dj. That is how it will look like. Then kutoka hapo, I have X and Y. So I have a column for X, a column for Y, a column for S1, a column for S2, a column for S3, a column for BI, and if need be, there will be a ratio. So this is X, this is Y, this is S1, S2, S3, then BI, and in case we will need a ratio.
Okay, so we record the values. We record the values. So I told you the essays come in with contributions of zeros. The essays come in with contributions of zeros. So kwa S1, hiyo equation ya kwanza, here this is 4, this is 3, there is 1 S1, these others are zeros. Alafu the total value is 240. The total value is 240. Then hapa tuko na 2, tuko na 1, tuko na 0, 1, 0, and this is 100. And then this one we have 0, this is 1, this is 0, 0, 1, and 50. Then the contribution margins, this is 14, this is 10, and this one tukasema zinakuanga zeros. These ones are zeros. Then I told you ZJs are always zeros in the first table. ZJs are zeros. And then tukasema DJ is CJ minus ZJ. So this is 14, this is 10, this is 0, 0, 0, 0. So as you can see, the table is not optimal. So I told you, you pick the highest. The highest is this one. And when you pick the highest, that one we said is called the key column. And this value here, we say it is called the incoming. Incoming. Shachukua hiyo, you go there now kwa issue. You divide these values using the values in the key column. So this will be 240 divided by 4. 240 divided by 4 is what? 60, eh? Is 60. 100 divided by 2 is 50. And 50 divided by 0 is infinite. Is infinite, a very high value. Sasa nikakwambia ukisha divide hivyo, we said that you take the smallest. You take the smallest, this one. When you take the smallest, the value here at the intersection of the smallest there and the highest here, the key row and the key column, this one tukasema inaitwa the key element. That value at the intersection. It's called key element. Then this value here at the title is the outgoing. It's the outgoing. So with that, you can be able to design the new table, the next table. You can be able to design the next table. So this is called second simplex table. second simplex table. This is column C. This is the basis. I told you the titles remain. So we are going to retain X here. We retain Y. We retain S1. We retain S2. We retain S3. BI and the ratio. So this is X, this is Y, this is S1, S2, S3, BI, and in case there is need, we will require the ratio, or we provide the ratio. So sasa tulisema unaangalia hii the old one S1 haijaguzwa, so it joins where it was S1. But you see S2 imekuwa circled, and we say that if they are outgoing, it is going to be replaced by this one. So this now becomes X. Everything else remains. S3 haijaguzwa, CJ, ZJ, and DJ. The contribution margin for S1 is 0. For X, it is 14. For S3, it is 0. Contribution margins. So what you do next from there, tulisema hivi. Unakuja kwa hii kilo, you divide everything by the key element. So utasema 2 divided by 2, 1. 1 divided by 2, 0.5. 0 divided by 2, 0. 1 divided by 2, 0.5. 0 and 50. And that becomes your new row. So tukasema now, you use the formula down here, which we said it is the new row, not new row. It is the old row element minus new row element multiplied by balancing figure. Old row element minus new row element multiplied by balancing figure. So tuanze na hii. Ukikuja kwa hii, the old row iko na 4. New row iko na 1. And the balancing figure, I told you, it is the intersection of the key column hapa na the value that you are dealing with. Rather, the row that you are dealing with. The row that you are dealing with. So that is 4. So the balancing figure. Sasa unachukua calculator. I told you, you just put them the way they are. Tuseme 4 minus 1 times 4, and you get a 0. Na iandika hapa. Then tunaenda kwa the next. This one 3. So you take 3. Kuja hapa kwa new row is 0.5. Balancing figure is still 4. So utasema 3 minus 0.5 times 4 is 1. So unaiweka hapo. We go to the next one. This one. So you say 1 times the neuro iko na 0. So it is 1 minus 0 times 4. It's 1. So unaiweka hapo. We go to the next one. The next one is this one, 0. The neuro iko na 0.5. So same 0 minus 0.5 times 4. It's negative 2. Negative 2. Haya, tuende kwa huyo mwingine kwa S3. Tuko na 0 kwa old row. The neuro tuko na 0. So it is 0 minus 0 times 4 is 0. And the last one is 240. The neuro iko na 50. So 240 minus 50 times 4. So we get 40 here. Get 40. Let us do the same with we had used 50. But what is the correct one? So let's go to the next. Here is 3. So the balancing figure is this one, 0. So utaanzia kwa hii ya kwanza useme ni 0 minus neuro hapa iko na 1. And the balancing figure tumesema ni 0. So that will be 0 minus 1 times 0 is 0. Tukuja kwa huyu mwingine who is here 1 and the neuro iko na hii 0.5. So utasema 1 minus 0.5 times 0 is 1. Utaweka hapo. Tuende kwa huyu mwingine wa 3, the value is 0. The neuro is 0, multiplied by 0, that will still be 0. We go to the next one. Tuko kwa S2. S2 hapa ni 0 minus this one iko na 0.5 times 0. So the answer will still be 0. The answer will still be 0. Tuende kwa S3. S3, I have 1. I minus the neuro iko na 0. Na balancing tulikuwa tumesema ni 0. So that gives us 1. That gives us 1. And the last one is old row. Huko iko na 50. Neuro iko na 50. The balancing is 0. So this gives us 50. CJ, I told you that has not changed. So we have 14 here. 10, 0, 0, 0, 0. Haya. Kuja kwa ZJ. ZJ, I told you, you take these values that are here, you multiply by these ones. So like now the first one, it will be 0 times 0 plus 14 times 1 plus 0 times 0. So the answer will be 14. Haya, huyo mwingine atakuwa 0 times 1 plus 14 times 0.5 plus 0 times 1, and the answer there will be 7. Huyo mwingine atakuwa 0 times 1 plus 14 times 0 0 times 0. The answer will be 0 here. The next one will be 0 times minus 2 plus 14 times 0.5 plus 0 times 0. That will also be 7. The next one will be 0 times 0 plus 14 times 0 plus 0 times 1. There, kila mtu ni 0. The next one will be 0 times 40 plus 14 times 50 plus 0 times 50. So 14 times 50, that is 700. That is 700. Kasema DJ is equal to CJ minus ZJ. DJ is CJ minus ZJ. So this becomes 0, this becomes 3, this is 0, this is negative 7, this is 0, this is negative 700. So you can see we are not yet up to Unahi. This is the highest. So you circle the highest. So when that becomes your highest, this one will be the incoming. That one, which is at that title of the key column. So what do? You now take these PIs, you divide by the values here. So 40 divided by 1, the answer will be 40. 50 divided by 0.5, that will be 100. And 50 divided by 1, that will be 50. So we take the lowest, this one. And when you take the lowest, this one becomes your balancing figure, and this becomes the outgoing. When you take the lowest, this becomes your not balancing, the key element. This becomes the key element, and this becomes the outgoing. So we need to design another table. We need to design another table. That's DJ, that's ZJ, that is CJ, at the first, the second value, the third value, the Pamtola. And this is the type. So this one now that I'm designing is my third simplex table. So this is C, this is basis, so this is X, this is Y, this is S1, this is S2, S3, and BI. I don't think we shall need the ratio, but okay, and it's like creates. So nimekwambia unakuja hapa unaangalia kama these values in the table have been touched. So you see S1 imekuwa touched, so it becomes the outgoing. It is going to be replaced by Y. So this is Y, X haijaguzwa, so X remains. This is F3, this is CJ, this is ZJ, and this is DJ. The contribution margin for X, for Y is 10, for X is 14, and this is 0. So from there, what next is unakuja kwa hii old table, the kilo hii yenye tulichukua the lowest, you divide everything by the key elements. So utasema 0 divided by 1 is 0, so unaiweka hapa. Then 1 divided by 1 is 1, hapo. 1 divided by 1 is 1. Minus 2 divided by 1 is minus 2. 0 divided by 1 is 0. And 40 divided by 1 is 40. That becomes our new row. So to get the other values, tutatumia ile formula yetu tumekuwa tukisema old row element minus new row element multiplied by balancing figure. Old row element minus new row element, you multiply by the balancing figure. Sasa tukianza hii X, this is the old row, so it is 1 minus the new row. New row iko na 0. Balancing figure, I told you, is the value at the intersection of the key column and the old row that you're dealing with. So this one, 0.5. 0.5. So sasa with that, utasema 1 minus 0 times 0.5 is 1. Naweka 1 hapo. Kuja kwa hii ingine. 0.5 minus 0 times 0.5. So 0.5 minus 0 times 0.5 is 0.5. Hapo. So I come to the third one here, 0 minus 1 times 0.5. So if I say 0 minus 1 times 0.5 is negative 0.5. Aya, huyo mwingine ni huyu y2 0.5 minus huko niko na negative 2 times 0.5. So utasema 0.5 minus 2 times 0.5. And I'm getting 1.5. 1.5. Then nikikuja kwa y3, kwa hapa niko na 0 minus pale niko na 0 in the new row. The balancing figure is 0.5. So 0 minus 0 times 0.5 is 0. Alafu the last one, kwa the old niko na 50 minus the new niko na 40 times the balancing figure of 0.5. So 50 minus 40 times 0.5 is 30. It's that. Aya, tuende kwa the next. The next here, sasa tuko kwa huyu. So the old is 0, the new is still 0, and the balancing figure now is this one. So 0 minus 0 times 1 is 0. There. Kuja hapa tuseme 1 minus 1 times 1 is 1 minus 1 times 1 is 0. Hapo kuja kwa huyu ni 0. Pale tuko na 1 times 1. So 0 minus 1 times 1 is negative 1. Aya, huyu mwingine ni 0 kwa S2 minus pale niko na minus 2 times balancing figure is 1. So this is 0 minus 2 times 1 is 2. So balancing figure that is 2. Huyo mwingine niko hapa kwa 3 now. That is 1 minus the new row is 0 times the balancing figure which is 1. So 1 minus 0 times 1 is 1. Alafu tukuje kwa huyu mwingine, the old iko na what? 50. And the new iko na 40 times 1. When you put in the calc, that is 10. You put in the calc, that is 10. So this one, tulisema this is 14, this is 10, and these are zeros. They remain that way. They remain. So if they remain, to get the ZJs, unachukua these values multiply. So itakuwa 10 times 0 plus 14 times 1 plus 0 times 0. So that must be 14. Haya, then hii ingine itakuwa 10 times 1 plus 14 times hii niweka vizuri kweli? What is supposed to be 0? Ilifaa kuwa 0.5. Kwani na nishuku, that should have been 0. So this is supposed to be 0, right? Yeah. Supposed to be 0. Because you are online, you can confirm that that was supposed to be 0. So even 0 plus 0 times 0. So I interchange, eh? Okay, so yeah, 10. I hope everything else was worked out well. Then you're getting 10 times 1 plus 14 times minus 0.5 plus 0 times minus 1. So 10 times 1 plus 14 times minus 0.5 plus 0 times minus 1 is 3. 10 times minus 2 plus 14 times 1.5 plus 0 times 2. So 10 times minus 2 plus 14 times 1.5 is 1. 10 times 0 plus 14 times 0 plus 0 times 1, kila mahali 0. And then the last one is 10 times 40 plus 14 times 30 plus 0 times 10. So 10 times 40 plus 14 times 30 is 820. Then this becomes 0, 0, minus 3, minus 1, 0, minus 820. So that table is now optimal because you can see all the values are either zeros or negatives. So if it's optimal, unarudi hapa unasema this is final simplex table. Final simplex table. Final simplex table. Final simplex table. So if it's final simplex table, then you give us now the optimal solution. Optimal solution. Optimal solution, I told you that in your case, you are supposed to give us two things. The first one is production. Production, we had two products, X and Y. We had two products, X and Y. Sasa unakuja unatafuta X, unakimbia huko mwisho, unapata iko na 30 units. Y iko na 40 units. The second thing you should tell us is the profit. And here we have maximum. So the maximum will be this value that is down here, 820. So the examiner had asked, these things that they are asking, the slack, the shadow price, They are not part of your syllabus. Sijui kwa nini wanashinda wakizileta. And they told us that they are not part of your syllabus. But this is how you go about them. So if they are asking for the SRAC, huwa tunasema hivi, you have the what? The resource here. Yeah? You have the resource. And then we have the SRAC through surplus. And surplus inakuwa the brackets. So our resources were S1, S2, and S3. Those are the resources. We were not given their names, but kama tungejua, you just put their names or you just put what was representing them. So you just do the same thing like tumefanya kwa X. Hii S1 unaona haionekani hapa kwa basis. So kama haionekani unaipea 0. S2 haionekani 0. But S3 iko na 10. I think we can also add another column instead of doing another table. Another column is the shadow price or the dual cost. This is what we are calling the DJ. That is something else that they are asking. Now, this shadow price of the DJs, they are the values of these S's hapa kwa DJ. Naona S1 iko na 3, so you just put them as positive. Huyu mwingine ako na 1 na huyu mwingine ako na 0. Those are the values they are asking. So you can see everything is there. It's only that the interpretation. But there is a lot that needs to be done for us to confirm these values. But that is the way they should be. So that brings us to the end of that paper and to the end of our today's lesson. So we hope to meet tomorrow to pick up from there. I think tomorrow it most likely it will be pure online. So we will pick up the next paper. So continue doing as we said. You can see today we have touched the topic of decision making, and we have touched the topic of what? The topic of simplexes, and the topic of time series and descriptive statistics. So tumeguza 4 topics. Tumeguza decision making, tumeguza descriptive statistics, tumeguza time series, tumeguza actually 5. Tumeguza probabilities, na tumeguza linear programming. So revise those topics. Revise.